What's going on, ladies and gentlemen? Welcome back to the Simulator series. In today's episode, we are going to be scripting the Pet Egg GUI that we made in the last episode. As always, if you guys do enjoy the video or it does help you out, make sure you smash the like button, also the subscribe button, and turn post notifications on if you want to get notified when I upload more Roblox development content. Additionally, I have a Patreon. If you guys like to support me and gain access to all the scripts and the game file I make during this episode, there's a link down below in the description, and you guys can go and check that out. With that being said, let's get into it. So, hopping directly into Eating Simulator to show off the functionality. In the last episode, we created this GUI that you're seeing right here, and what we're going to be doing in this episode is scripting it so the entire GUI is populated with all of the individual pets, as well as when we hover over them, it'll display the chance of hatching that pet, and we'll also implement hatching an egg and selecting a random pet for that egg. And this entire system will work for multiple eggs, so not just the basic egg, but also another egg as well, so that we can see how we can easily do this with multiple different eggs. Hopping directly into Studio, the first thing that we want to do is we want to actually add some pets to our game. Now, I'm going to be using this free-to-use pet pack by Aziuus. Hopefully I'm pronouncing the name correctly. I'll leave a link down below in the description to get the pet pack. Now, from this pet pack, we're going to choose just a couple of pets out of it because we're not going to use all of them during this tutorial. So the ones that I'm going to take are the bunny, the cat, the dog, the fox, the pig, and the turtle. So we're going to highlight all those, hit Control X. Then inside of the replicated storage, we're going to create a folder and we'll rename this to pets, and we'll paste all the pets that we just selected directly into this folder. So now that we've got a couple of our pet models, what we then want to do is inside of the config folder, we actually want to create a config module for the eggs. So we'll insert a new module script and we'll rename this to eggs. And then inside of the module table, we'll create our first egg. So we'll say basic underscore egg equals, which is going to be another table. And then this table is actually going to be an array of more tables. So we'll create a new table inside of here. And inside of here, we're going to add some properties for each of the individual pets that you can hatch from this specific egg. So first we're going to say ID, and we're going to set that to the ID of the pet that we want to hatch from this egg. So let's say that the dog is one of the pets that we want to hatch from this egg. We can also set the rarity as well. So for the dog, we want a common dog to come from this egg. And then we'll set the chance of hatching a dog from this egg. And now this will actually be the most common pet from this egg at a 15% chance. Then we can just copy and paste this table and just change around some of the information. So the next pet that we want to be able to hatch from this is a bunny. It'll also be common, but the chance of this is actually going to be 10 instead of 15. We can duplicate that once again. Then for the cat, it'll be the exact same as the bunny. We want it to be common and we want it to be a 10% chance. We'll copy it again. This time we want to hatch a fox with a 7.5% chance. Then a turtle, which is actually uncommon, and that'll have a 5% chance. And lastly will be the pig, which will be rare, and it'll have a 3% chance of hatching. Now, obviously, you can set up the egg however you want to, and all of the pets as well. This is, of course, just for demonstration purposes. Now, we'll use this config file later to display all of the pets which can be hatched from the egg, along with their rarities, and along with their chances of actually hatching those. And then on the server side, we'll also use this when deciding what pet to actually hatch from the egg. So now we need to actually create a handler for the GUI or the Billboard GUI that we created in the last episode. So inside of the starter GUI, we have the eggs folder, and then we have our little template Billboard GUI right here. Let's go ahead and create a local script, and we'll just rename this to handler. Then inside of here, we want to get the workspace service. So we're going to say local workspace equals game get service workspace. And we're also going to get the replicated storage as well. Now we need the workspace because we want to actually get the eggs folder right here, which holds all of the egg models that we're going to want to add a GUI to, such as the basic and the rare egg right here. So we'll create a variable for the eggs folder. So we'll say eggs folder equals workspace.eggs. And now we have the eggs folder. And we're also going to need to get the pet models. So we'll get that from the replicated storage. So pet models equals replicated storage.pets. And we could even name this pets folder to keep it consistent with the eggs folder variable that we just created, but we'll leave it named as pet models. We're also going to need to get that egg config that we just created. So we'll say local egg config equals require replicated storage.config.eggs. And then lastly, for right now, we're going to need to actually get the template GUI, which is in the same folder as our handler. So we'll say local template. You could name this template GUI. It doesn't really matter. Equals script.parent.template. And now we have the template Billboard GUI. Then let's go ahead and create our first function, which is actually going to be called generate Billboard GUI. And inside of here, we'll accept the egg model, which is going to be a model, but we're actually going to get the instance of a model. And then we'll also pass through the egg config as well, which is going to be a table. Let me show you an example of how we're going to actually be calling this function. So we're going to say generate Billboard GUI. And for right now, we'll use the eggs folder and we'll just pass through the basic egg. And that'll be the egg model. And then for the egg config, we'll pass through the egg config dot the basic egg. So of course, for the config, it'll actually be this array right here, by the way that we're calling this. And then also remember, inside of our egg models, which is inside of here, each of the egg models has an attachment inside of it. So inside of our function, let's go ahead and create a variable for that attachment. So we'll say local attachment equals egg model dot attachment. Then once we have that attachment, we want to actually create a clone of our template Billboard GUI. So we'll say local clone equals template, clone. And then we want to make sure that we parent this, and we're actually going to parent it to this folder that we're currently inside of right now, which is going to be the eggs folder. So we're going to maintain all of the Billboard GUIs inside of this one folder. And since we're parenting it to the folder that we're currently inside of, we need to make sure that we set the Adornee to the attachment so that the Billboard GUI is displayed on that specific attachment. And then we also want to rename the GUI from template to whatever the egg actually is called. So we'll just say eggmodel.name. Then let's look inside of the actual template, and inside of here we can see that we have the frame, and then we have the title frame, which inside of here we have the title text label, and the same goes for the price as well. So let's set the both of those. So we'll say clone dot frame dot title dot text equals eggmodel.name. And remember, we learned about gsub in the last couple of UI tutorials. This basically allows us to find and replace a specific character or set of characters within the string that we're using this method on. So we'll say underscore, and we're going to replace that with a space. And then we also want to set the price as well. So we'll say clone.frame.price.text equals, and now we need to make a way to figure out the price of the egg. So what we'll do is we'll actually modify the egg config slightly. So inside of the basic egg config, we'll add a new field to this, and we'll say price. And we'll just say the price of this is 2,000 coins. Now for all the pets, we want to actually create another field inside of here, and we want to say pets. And we're going to set that equal to basically what the egg originally was, which was just an array of all these different pets. So the basic egg is now a table with a field of price and pets is now the table, which is also an array of all of the individual pets with the rarities, the IDs, and the chances. So now going back to the handler, we can now get the price of the egg by saying eggconfig.price. So now let's go ahead and test this out. The first thing that we want to make sure that we do though is for the original template, we still have the Adornee set for the basic egg. So what we'll do is we'll just actually set that to nothing so that this doesn't automatically display on the basic egg when we start up the game, and we can verify that the script is working. And of course, make sure that you're actually calling the method, and make sure that you're passing through the basic egg model and the basic egg config just exactly like how we did. Then we can go ahead and start this up and verify that it works. So upon starting up our game, we can walk over to the basic egg, and we can see that the price is directly down here. We have the name set to basic egg, although I'm pretty sure we set that by default anyway, but we are seeing that this GUI is popping up, which means that everything is working correctly. Let's quickly adjust the price though to make the string actually be displayed how we want it to. So we want to actually display our like little money icon right there, and then we'll combine that with the price, and that's how the price should be displayed. The next thing we want to do is we want to start populating the GUI with all the pets that can actually hatch from this egg. So let's go inside of the replicated storage, and we actually need to set the primary part of every single pet model for each of the different pets, because we're going to be displaying these within a viewport frame. So let's go ahead and drag all these outside of the replicated storage back into the workspace so that we can actually view and see them. And then we'll start with the bunny. What we want to do is we want to try to set the primary part to be the main square of the actual pet. So we're going to try to avoid setting it to something like the feet or the ears or other things like that. We want to just try to set it to the main square. And if you're unfamiliar with setting the primary part of a model, you click on the model, it has the primary part property right here, and then you just click that and select whatever part you want to set the primary part to. So we've got the bunny done, and then for the cat, we found the face, so let's just go ahead and do that. For the dog, we found this one as well, and then we just have to do it for the fox, the pig, and the turtle. All right, so now that we have the primary part set for all of those pets, we can go ahead and drag them back directly into the replicated storage, and then we can go back to the handler and start working on generating all those pets. So we'll create a new function above the generate Billboard GUI function called generate pet, and what this will accept is the container, which is going to be a frame, and the pet config, which is going to be a table, and what I'm referring to by the pet config is going to be any of these specific tables. Now, how we're planning to call the function is we're going to use a for loop. So we're going to say for underscore pet in I pairs egg config dot pets do, and then we'll just say generate pet, and we'll pass through the clone dot frame dot container, because remember, inside of the Billboard GUI we have this container frame right here, and then we also want to pass through the pet, which is going to be given to us by using this for loop. And then also inside of the container we already have a text button named template inside of here. So inside of our generate pet function, we're going to say local clone equals container dot template clone. We'll then set the parent of the template to the container. We want to set the name of the clone to pet config dot ID. We want to make sure that it's visible, so we'll say clone.visible equals true. And then inside of the template, we have the pet name and the pet rarity text labels. So we want to say clone.petName.text, and we want to set that to the petconfig.id. And we'll probably want to use the gsub method on this as well, in case any of your pets have underscores in their name. So we can just say underscore and replace that with a space. And then we also want to set the pet rarity.text to the pet config config.rarity. And then also for the rarity as well, we want to change the color of the rarity text based on the rarity of the pet. So what I mean by that is that the common rarity is sort of a darkish gray, the uncommon is a green, and then the rare is a blue. So then let's create a function above this function called getRarityColor, and we're just going to pass through the rarity, which is going to be a string. And then we'll say local color, and we'll say if rarity equals common, then color equals color3 dot from RGB 255 255 255, as that's white. And then we can pretty much just copy and paste this. So we'll say else if rarity equals uncommon, then, and this time we want a like lightish green, so maybe something like that. And then we can say else, but I'm just going to create another else if statement here, and we'll say else if rarity equals rare. And then for this we want a kind of lightish blue, so something like that. And then finally we just have to return the color. Then we'll do is back inside of the generate pet function below where we set the text of the pet rarity, we're going to say clone.petRarity.textColor3 equals getRarityColor, and we'll just pass through the pet config.rarity. So now we're setting the color of the text based on the rarity. And now just to quickly make sure everything's going good, let's go ahead and start up our game. We can then come over to the GUI and we can see that this is all working correctly. The only thing that we really need to do is set the visibility of the default template to false so that the first one isn't displayed, but we can just ignore this one for now. Anyway, we can see the dog, bunny, cat, fox, turtle, and pig are all displayed, starting from common to uncommon to rare. And the only thing I'm noticing is that we probably want to just change the common color from a white to a gray because I kind of messed that up. But other than that, everything's looking pretty good. We also need to add the viewport frame, and that's what we'll be doing next as well. So we'll quickly adjust the common color from being white to being more of a darkish gray, and that looks pretty good. And now we can start working on creating the viewport frame. So let's actually create a function up here called generate viewport frame. Inside of here, what we'll accept is actually a viewport frame, which of course is going to be a viewport frame, and the pet model, which is going to be a model. So back inside of the generate pet function, what we want to do is we want to get a clone of the specific pet model from our replicated storage. So we'll say local pet clone equals replicated storage dot pets, and then we'll index that folder with the pet config.id, and then with the model that we find, we're going to clone. Actually, I forgot we made a variable for this, so we don't have to say replicated storage.pets. We just have to say pet models, and then we have the folder so that we can index it with the ID and clone it. And then we'll pass the viewport frame of the clone. So clone.viewport frame, and then we'll also pass through the pet model as well, so the pet clone that we just created. Of course, make sure your viewport frame is spelled correctly when you're passing it through here, otherwise you're going to have an error. Now back to the generate viewport frame function. What we want to do is we want to set the primary part C frame of the pet model. So we're going to say pet model set primary part C frame. This is why we set the primary part on the model. Otherwise, we wouldn't be able to do this. And we're going to create a brand new C frame. And what this C frame is going to be is this is actually going to set the position of the model that we just created. So we could say 0, 0, 0, or we don't have to put anything in here. And by just saying cframe.new, that is the equivalent of saying cframe.new and putting 0, 0, 0 inside of here. So that's going to set the position of the model. And then we'll multiply this C frame by cframe.angles. And this actually allows us to set the angle at which the model is currently positioned at. So based on how our pets are currently set up and how we're going to be setting up our viewport frame and the camera for the viewport frame, we want the X angle to be 0, the Y angle to actually be math.rad 90 because we want it to be turned to the side a little bit. And then for the Z angle, we want this to be 0 as well. And now if this is confusing to you, don't worry. Viewport frames are a little bit more complicated, and C frames is also another thing that's a little bit complicated. So if you don't know too much about these, don't let yourself get too stumped. Just kind of keep following along with the tutorial, and you can learn about the C frames and viewport frames on your own time. In my opinion, these are some really nice things, and eventually you should know them, but don't get stuck on them for too long. If you are stumped, just try to get it set up however you like it or however it'll work for your system, and then try to move on from there and come back to them at a later time. Because from my experience, when I was first starting to try to learn C frames and work with the viewport frames, I had a lot of difficulty and had a lot of frustration as well. So if you're in the same boat as me, don't feel bad. Just try to keep moving on and keep learning eventually. Anyway, now that we set the C frame of the primary part, the next thing that we need to do is we actually need to parent the pet model. So we'll say pet model.parent, and we're going to set that to the viewport frame. Then we need to create a camera for the viewport frame. So we'll say local camera equals instance.new, and we'll create the camera, and we're going to set the parent of the camera to the viewport frame. And then we want to set the viewport frame property called current camera to the camera that we just created. And then we also need to set the C frame of the camera that we just created. So we'll create a new C frame by saying cframe.new, and we'll set the position of the C frame by using event vector 3, and we'll set that to 0, 0, and 4. And now up here, I understand that when we're setting the position, we're using a cframe.new, which is slightly different than a vector3.new. But imagine that we set the position of the primary part cframe to 0, 0, 0. Now we're setting this to 0, 0, 4, which in a way sets the camera about 4 studs away from the actual pet model. And if this is complicated for you at all, think about it in this way. If you're taking a picture of something, you don't want to literally be inside of the thing you're taking a picture from, right? You want to be a little bit further away. So that's why we're setting the position 4 studs away from what we actually set the pet model to. And then for the orientation of the camera, we're going to set that to the pet model, and we're going to get the primary part of the pet model, and we'll get the position of the pet model. Once again, if you're confused at all by the viewport frames or the cameras and the C frames and everything like that, don't feel bad. I even struggle a little bit with this to really articulate or teach people why all this stuff comes together and what everything exactly does. Maybe someone in the comment section could explain it better for anybody who wants to know more or understand it a little bit better. I'm still not perfect or even really good when it comes to C-frames and knowing everything that goes into it, but I'm trying to explain the things that I really do understand and at least give us a working product so that you guys don't have to go through all the struggles of learning it all on your own. All right, so now that we have that function created, remember we already called this when we first created the function, so we cloned the actual pet model found inside of the replicated storage, and then we pass that through to this function. We also pass through the viewport frame as well. So let's go ahead and start up our game and see how these turned out. So if we come over to our pet GUI, we can actually see all the pet models are displayed very nicely right on our GUI, which is really, really good. Now let's make some minor adjustments to the actual GUI itself. So inside of the GUI, we have the container and then we have the default template right here. Let's make the template not visible by default. And also for the viewport frame, we want the background transparency to be 1 because we don't want to see that white background behind our pets. And additionally, remember inside of the generate viewport frame, remember how I was describing the vector 3 that we created here gives us a little bit of a distance away from our pet model. If we maybe wanted to make the pet appear a little bit larger or say take a picture from closer towards the pet, we could change 4 to 3 and that'll basically put us a little bit closer to the pet and kind of display them as a little bit larger inside of the GUI. And now we see maybe even 3 might be a little bit better because they appear a little bit larger. But the other thing that you kind of have to worry about is with the bunny, we can see the ears are kind of poking out of the frame a little bit. So you do have to worry about that a little bit. If the distance isn't far enough away from them, then all the aspects of them might not appear inside of the frame. But if you're too far away from them, they might appear a little bit too small for your liking. So you want to find a good balance between both of those things. I actually don't mind the bunny's ears popping off a little bit, and I really like the size, so I think we'll leave it as is. So the next thing we want to do is back inside of the generate pet function. We actually want to set up displaying the chance of hatching a specific pet whenever you hover over that pet in the GUI. So we're going to say clone.mouseEnter, which is an event of all buttons. And actually, to make this a little bit easier, we can set the type of the clone to be a text button, as that's what the clone actually is. So now it'll automatically fill in when we're typing this stuff out. So now we see we have mouse enter, so then we can easily say connect, create an anonymous function inside of here. And what we want to do is whenever the mouse is hovering over the text button, we want to actually set the pet rarity text to the chance of hatching the pet. So we're going to say clone.petrarity.text equals petconfig.chance. And then whenever the mouse is not hovering any longer, we want to say mouse leave. We're going to set the pet rarity text back to the actual rarity, just like that. So once again, we can start up our game, test this out, and verify that that all works. Going into our game, hovering the mouse over it, we can see that the rarity has been changed from rare to 3, and the same goes with all of these as well. Now, the only other thing that we might want to do is actually add a % symbol after the number, so people understand it's going to be like a 3% chance, and etc. And there we go. Now that's all good. So now we should be pretty much done with the generate pet function. Let's go back to the generate billboard GUI function. And now if we just look back at the billboard GUI, we can see that we have the buttons frame right here, which holds 3 different buttons. And we of course want to do something when these buttons are clicked. So we're going to say clone.frame.buttons, and we can start with auto.mousebutton 1 click, connect, function, and then let's just duplicate this 2 more times so that we can listen to all the buttons being clicked. So then we have ×1, and finally we have ×3. Now for the auto button, we most likely want to check if the player actually has this unlocked, and if they do not have this unlocked, we want to prompt them to purchase the game pass. So depending on how you guys have your data set up for the game passes, you could say if player, and we actually have to get the player. So let's go back up to the top and get the player's service, and then we just create a variable for the player. So local player equals players.local player. Then coming back down to here, we can say if player.gamepasses.3.value, then, so this would mean if the player does own the game pass, but let's say if the player does not own the game pass, then we would want to prompt them to purchase the Game Pass. So then you can prompt them to purchase the Game Pass. Otherwise, if the player does actually own the Game Pass, we'll do something else, and we'll get to that in a minute. And I actually made a mistake here. I said ×3. Realistically, we would be checking the auto, but we would also do the exact same thing with ×3 as well. So instead of saying auto, we're going to check if they own the Game Pass by going through their player data and checking the Game Passes and then checking the ×3. And if they don't own it, then we're going to prompt them to purchase it. Otherwise, we'll do something else as well. Now for ×1, this is going to be the free hatching that everybody has access to. You just open the egg one time, simple and basic. Now we need to create a remote event so that we can communicate from the client to the server and tell the server, hey, we want to open up this pet egg right here. So going back inside of the replicated storage, inside the remotes, we can create a new remote event, and we'll just rename this to buy egg. And then of course we need to create a variable for it. So we'll just say local buy egg equals replicated storage .remotes.buy egg. Then back inside of the ×1 button click listener, we're going to say buy egg fire server, and we'll just pass through the egg model.id, and we'll just pass through the egg model.name. And then for the auto and ×3, we would actually do the exact same thing, but we'll pass through an extra argument. So inside of the ×3, if the player does own this Game Pass, what we would want to do is we would want to fire the server, but instead of just passing through the name of the egg, we'll also pass through ×3 so that we know that this is sort of like the little modifier that we're going to use while hatching the egg, and this is a specific button that we pressed. And we'll do the exact same thing for the auto, but instead of passing through ×3, we'll pass through auto. Now I'm going to actually comment out all of this stuff right here, as we're not going to implement the data of checking if we own the Game Pass or not. The same goes for the ×3 as well, so we're just going to leave that as is. Otherwise, we would be running into errors in our own game. If you want to add the ×3 and the auto to your game, you guys certainly can, and I'm giving you guys sort of the blueprint to do that on your own. Now we want to create a server script for listening for the communication from the client telling us, hey, we want to open up this egg. So let's go inside of the server script service and create a brand new script, and we'll rename this to eggs. The first thing that we want to do is we want to get the replicated storage, and we also want to get the workspace as well. Let's create a variable for the eggs folder, just like we did in our handler script. So we'll say workspace.eggs, and then we have the folder. We also want to get the eggs config, which will require from the replicated storage.configs.eggs. And then finally, we want to get the buy egg remote from the replicated storage.remotes.buy egg. There we go. So let's listen for the buy egg remote to be called. So we'll say .on server event connect function. The first argument is of course going to be a player, because whenever a player calls a remote, it's always going to pass through the player who called it. Then we'll get the egg ID, which is going to be a string. And finally, we'll get the modifier, which is also going to be a string as well. You could say modifier, or another way to think about it is the action. So ×3 or auto would be the action. Then we'd say if action equals auto, then we would do something right here. Else if action equals ×3, then we would do something specific to the ×3, or if it doesn't equal either of those, then we'll just hatch like normal, and we'll create a function for hatching in a minute. Now the first thing that we want to do whenever we call this is we want to check if the player can actually hatch the egg. So we want to check first of all if the egg actually exists, because an exploiter could pass a random string as the egg ID, and that could cause an error when we're handling this. So let's go ahead and create a function called canHatch, which will accept the player as a player and the egg ID as a string. So first let's get the egg config. So we'll say local egg config equals, and then we'll index the eggs config with the egg ID that were provided from the client. And then we'll actually check if the egg config exists. So if the egg config does not exist, then it'll equal nil. So we'll say if not egg config, then return end. So if we're unable to find the actual config, then we'll stop the function right there. Otherwise, if we're able to find the egg config, then let's actually get the player's balance, so the amount of money that they actually have. And for us, that'll be set to player.leaderstats.coins.value. And then we can check if the player has enough money to actually open up the egg. So if player balance is less than egg config.price, then we're just going to return false and end. So if the player does not have enough money to open the egg, it'll return false and stop the script there. Otherwise, we'll return true. So if the egg config is not found because either we made a mistake or there's an exploiter try to mess with our system, then it'll stop the script right here and return nil. We could also return false as well. Nil or false will work for how we're going to use it. And then we're going to get the player's balance, and we're going to check if the player has enough money to open it. If the player does not have enough money, then we're just going to return false and stop the script there. Another way to write this, which is even cleaner, is saying return if the player balance is greater than or equal to. So if the player is able to hatch the egg because they either have exactly enough money or they have more money than the egg's price, then we'll return the result of that. So you can write this either way you want to. I'm just showing you guys multiple ways of how to do that. Then back inside of listening the remote to be fired, we're going to say if not can hatch, and we'll pass through the player and the egg ID, then return end. So if this check does not return true, then we're just going to stop the function right there and not run anything else. Next, let's create a function above the canHatch function, and we'll actually call that hatch. We'll pass through the player and the egg ID. Now, each time you open up an egg inside of a simulator, you kind of have a little animation that plays, which sort of acts as a small cooldown between opening eggs. So in a way, it prevents you from opening up like 20 eggs in a second. So what we'll do is we'll actually create a table called hatch cooldown, and that'll equal a blank table for now. And above here, we want to actually create a variable for the specific cooldown. And we're just going to say hatch underscore cooldown, and we're going to set that to 3. So we'll have a 3-second cooldown each time a player successfully opens an egg. So when we call this function, the first thing that we want to do is we want to check if the player's user ID is within the hatch cooldown list. And if it is, then we're just going to return N because we know that the player is currently on cooldown. Now, otherwise, if it's not, then we're going to add their user ID to the list, and we'll just set it to true. Next, we'll get the egg config, just like how we did in the can hatch function right here. So we can literally just copy and paste that. And we also want to get the player's balance as well. So we'll just do that again. And similar to how we did a check inside of the can hatch function by checking if the player has enough money to open the egg, we'll also take that if statement and change it to what we originally had it. So if the player balance is less than the egg config.price, then just return N. So don't do anything below this line. But if the player does have enough money to open the egg, then what we want to do is we want to subtract the price of the egg from the player's balance. So we'll say the player's current money minus equals egg config dot price. And now we actually need to choose the pet from the egg that the player is going to get. Also, another thing that we might want to do to make this a little bit better is we might only want to set the cooldown to be active if the player can purchase the egg. So if the player has enough money. So once we determine that the player does have enough money to purchase the egg, and right before we take the player's money, we'll actually set the cooldown right here. Now let's create a function for determining what pet the player gets from the egg that they just purchased. So we'll say local function choose pet, and we'll accept an argument called pets, which is going to be a table. So then when we call this function, we're going to say local pet equals choose pet, and we'll pass through the egg config dot pets. And remember, the pets is the table right here, which holds all of the pets inside of it. Now for the choose pets function, we're going to be using the logic posted to the developer forums by LordOfMelons. So shout out to him for posting the logic to a system which will actually choose a random pet based off different rarities. So with that being said, what we're going to do is inside of this function, we're going to create a new variable called total weight, and we're going to set that to 0. Then we're going to loop through the pets table. So in I pairs pets do, and we'll add the chance of each pet to the total weight. So total weight plus equals pets dot chance. Then outside of that for loop, we're going to create another variable called chance, and we'll set that to math dot random, and this is going to spit out a number between 1 and the total weight. Then we'll create another variable called counter, and we're going to set that to 0, and then we're going to loop through the pets again. So we'll say for underscore pet in I pairs pets do, and each time we loop through, we want to add the chance of that pet to the counter, and then right below that, we want to check if the chance is less than or equal to the counter. And if it is, then we want to return that pet. And that's how we can easily choose each pet based off its rarity. So now going back to the hatch function, we're already calling the choose pet function. So then for now, we can print you got a dot dot pet dot rarity dot dot space dot dot pet dot ID. And now that'll print to the console which pet we actually hatch every single time we hatch an egg. So back down to when the buy egg event is actually called, inside of the else statement, we will call the hatch function. We'll pass through the player and the egg ID. And then inside of the handler, we're already calling this function. So we're going to go ahead, start it up, and then we can test this out. So we'll come over to the egg. We can see it's all displayed very nicely. We can click on ×1. I see it made a slight mistake right here. Inside of our egg server script, inside of the choose pet function, I tried to index pets, which is the list of pets and not the individual pet with the dot chance. So we need to change it from pets to pet dot chance, and now we can start it up and test it, and it should be good. So we come over to the GUI, we open it up, and we can see that we just got a cat. Now we can try to open it up again, but we're actually still on cooldown. So we need to actually remove the cooldown from the player, as we forgot to implement that. Back inside of the hatch function, what we want to do is we want to say task dot delay, and we want it to be delayed by the hatch cooldown, so it'll wait 3 seconds, and then we want to create an anonymous function, and then we'll set the hatch cooldown, index the player dot user ID, and we'll set it to nil so that this removes the player from the hatch cooldown list. So we can start it up again and test this out. Let's go ahead and hatch a pet. We can see we once again got the common cat. We'll hatch it again, and we can now see we got the fox, we got the dog, and if we keep hatching, we'll keep seeing that we get different pets. After a couple of times of hatching it, we actually got the turtle, and we can just see from this short test right here, it does seem to be working with the percentages, as we still haven't gotten the pig, and we only got the turtle 1 time out of all the times that we've hatched so far. Now, how will we communicate from the server to tell the player which pet that they actually just received? Well, we could use a remote event. So we can add a new remote event to the remotes folder, and we can rename this to maybe something like pet hatched or egg hatched or something like that. And then all we have to do is make a variable for this inside of our script. So we can say pet hatched. We'll rename the variable to pet hatched as well. And now we can fire client with this. to the player, and we can pass through the pet table. And then from the client, we can listen to whenever this remote is fired. And now we can remove this print statement. And if we want to, we can go back to the handler script and we can create a variable for this remote. So instead of just by egg, we can say pet hatched, and then we can listen to whenever this remote event's fired. So on client event, connect, function pet, which will be a table, and we can do the print statement that we just did on the server end. So we received a ... pet .rarity ... space ... pet .id. And now we can start this up, hatch a pet, and we can see that from the client, this is now being printed. So we received a common dog. So from there, you could easily implement and add in your own animation or your own special little GUI for whatever happens when you receive a pet. Now, the next thing that we need to do is add the capability of listening for whenever a player presses either the T, E, or R key on their keyboard. And based off of that, we'll perform an action of the UI. So for example, if they press T, we'll do the exact same thing as if they were clicking the ×3 button. If they press E, we'll do the same thing as if they were pressing the ×1 button. And if they press R, we'll do the exact same process if they click the auto button. Now, the way that we're going to handle this is by using the user input service. So we're going to get that up here. Now, towards the bottom of the script, but above the pet hatch remote, we're going to say user input service dot input ended connect function, and inside of this function we'll get the input, which is an input object, and game processed event, which is a boolean. So the first thing that we want to do is we're going to say if game processed event, then return end. And when the game processed event is true, for the most time, it's usually if it's sort of like a hotkey that interacts with Roblox default systems. So for instance, if we're listening for the tab key to be fired, the game processed event will usually return true, because when you press tab, the leader stats leaderboard either becomes visible or is hidden. Now, you might need to change this based off your own games. You could even delete it. It's not too big of a deal, but we're going to use this for now. And then we also want to check the user input type. So if not, input.user input type equals enum.user input type.keyboard, then return end. So if the player is not using a keyboard, then we're just going to stop the function there. Finally, we can start doing things based off of the specific key the player presses. So if input.keycode equals enum.keycode dot, and for the first one, we'll be using the T key. So if it equals T, then we'll do something. Else if the key code equals E, then we'll do something. And then finally, else if the key code equals R, then we'll also do something. Now let's go ahead and create a function above the generate billboard GUI, and we're going to say local function request hatch. And inside of this function, we'll accept the egg ID as a string and the action as a string as well. And now we can copy the logic that we already created inside of each of the specific button clicks and basically paste it into here. So first we're going to say if action equals auto, then, and then we'll paste the logic inside of here. And then of course, instead of firing server with the egg model.name, we'll fire it with the egg ID instead and the auto action as well. And then we'll say else if the action equals ×1, then, and then we'll use this logic right here, which once again, using the egg ID instead of the egg model.name. And then finally, you could use an else statement, or you can use an else if statement. If the action equals ×3, then we will use this logic down here. So there we go. Now that we've created this function and taken all the logic from the buttons, what we then just need to do is we then just need to recall the request hatch function with the correct egg ID and the action. So we're going to say request hatch egg model.name like we did previously, and then the action. So if we click on the auto button, then we're going to pass through auto. If we click on the ×1 button, then we're going to pass through the ×1. And if we click on the ×3 button, then we're going to pass through ×3. Now we've created that because we're also going to be doing the exact same thing down here inside of the key code. So for T, that's going to be ×3. So we're going to say request hatch, and currently we don't have the egg ID, but we'll create that in a sec. So let's just go ahead and create a variable up here called local egg ID. And we'll just set that to a blank string for this second so that the request hatch isn't throwing an error. And remember, T is ×3, not auto. So then we have that set up. And now for E, that would be ×1. And for R, that is auto. So now we need to create a function for getting the ID. And now the simplest way of doing this would be getting the closest egg to the player and seeing if they're within the range at which the GUI can be displayed at. So let's create a function right above input ended. We'll say local function get closest egg, and we won't accept any variables. So inside of this function, we're going to create a variable called closest, and we're going to set this to a table and kind of input fake data currently. So we're going to say egg equals nil and distance equals 9,999. And we'll see why we're doing that in a second. Then what we're going to do is we're going to loop through each of the eggs inside of our eggs folder. So for _egg in iPairs eggs folder, get children, do, and then we need to get the distance. So local distance between equals player.character.primary part, or you could even get the humanoid root part, but we'll just say primary part. So player.character.primary part.position. So basically the position of the player minus the egg.position. .magnitude, and now we have the distance between the two parts. So then we want to check if the distance between them is even close enough to be displayed. So if we look inside of the template and we look at the max distance, it's 17. So we can say if display distance is greater than 17, then continue end. So if most likely the GUI wouldn't be open because the distance is too far, then we'll go to the next egg and check that distance. Now, if the distance between is small enough, meaning that they're close enough for the GUI to be open, then we want to check if closest.distance is greater than the distance between. So basically, if the last closest egg is actually further away than the current distance between, then we're going to set closest to a new table with the egg equaling the egg dot name and the distance to distance between. And that's pretty much it for the loop. So it's going to get the distance between the player and each of the eggs. It's going to check if the distance between the player and the egg is greater than 17, which is the max distance that the GUI can even be displayed at. Then it's going to check the next egg and do the same thing. But if it's possible for the GUI to be open because the distance between is smaller than 17, it's then going to check the last closest distance, and it's going to compare that to the current distance between the player and the current egg inside of this loop. And if the previous distance is greater than the current distance, then we're going to update the closest table with the new closest egg to the player. So then finally what we're going to say at the bottom after the for loop is we're going to say return closest dot egg. And then back inside of when we listen to the input ended, we're going to call the get closest egg function, and then we'll say if not egg ID, then return end. So if the egg ID is nil because the player was not in the range of any of the eggs, then we're just not going to do anything. Otherwise, if the player is within the range, then we're going to fire the request hatch function, which will run one of the actions. So now we can start the game up again and test this out. So if we go over to the GUI and we click the button, we can see that we actually are hatching a pet. And now if we click the E key, we can also see that we're hatching a pet as well. And we just got the cat once again, and we're actually having weird luck. We just got the cat 3 times in a row, but now we see we also hatched the fox, and that's working exactly as it should. So now the final thing that we're going to do is create another egg config so that we can see how we can easily call the generate billboard for multiple eggs. So if we look inside of our eggs folder, we have the basic and the rare egg. We'll duplicate this basic egg config by copying and pasting it just like that. And now we'll rename this from basic egg to rare underscore egg. We'll change the price from 2,000 to 5,000. And now let's say we want the dog to be rare. We don't want there to be any bunny or cat, and we'll have the fox as rare as well. And I guess that's it. We'll just have the dog and the fox both being rare, and the chances of getting these will be a 5% and a 2.5%. And actually, I messed up with the price. We want it to be 5,000, not 52,000. Okay, so there we go. We now have our quick little config set up. So right where we call the generate billboard GUI function, we're going to loop through the eggs config. So we're going to say for egg name, comma, egg config. We could say name and config, but this makes it a little bit less confusing. In pairs, egg config do generate billboard GUI eggs folder, and we'll index that with the egg name, comma, egg config. And now we can remove the generate billboard function because now, like I said, it's going to loop through each of the eggs that we have set up in our config, and now it'll call the function for each of those eggs. The other thing that we want to do is we probably want to move the eggs a little bit further away from each other. So we'll move this rare egg like about over here, and then we can start our game and test this out. So now we can see we can walk over to this egg right here, and we have the basic egg being displayed with all of the pets inside of it, and we can hatch it, and we see we get the common bunny. But we can also walk over to this egg over here as well, and it's displayed a little bit further down because remember, we have the attachment set up differently between the two. But anyway, we can now see the contents of this being generated. So the rare dog and the rare fox with their chances of hatching, so 5% and 2.5%. And then we can press or click on E, and we can now see we received a rare dog. So these are both working exactly as they should be. Okay, so we've done a lot in this episode. Anyways, ladies and gentlemen, with that all being said, I hope this guide did help you guys out. It was a lot of work and a lot of effort. If it did, make sure you guys smash the like button, also hit the subscribe button, and turn post notifications on if you want to get notified when I upload more Roblox development content. Of course, I do have a Patreon. If you guys like to support me and gain access to all the scripts and the game file that I made during this episode, there's a link down below in the description, and you guys can go and check that out. With that being said, I hope that you guys have a great day, and I'll see you guys in the next episode.